Vice President of NIMPA, Alderman and Chairman of the Public Utilities Commission, and Robert Ruggie is our electric superintendent. From Rochelle is Edward Carr. He's the Secretary Treasurer in NIMPA. General Manager of Rochelle Municipal Utilities. And Joe Orlowski, Electric Operations Superintendent. I'd like to introduce our NIMPA's management consulting team who are here. Raj Roll, the President and CEO of Indiana Municipal Power Agency. And Chairman of the Board of Prairie State Generating Company. Chris Reddick, Senior Vice President and Chief Financial Officer. And Larry Brown, Vice President of Resource and Planning. And from Prairie State, we have Peter DeQuattro, President and CEO. From City, and just to give you an idea what City is, City has been the NIMPA Senior Manager on the bond sales we have done to date and the upcoming bond issues. That means that we have co-managers, and City is responsible for leading that effort in selling the bonds and coordinating the co-managers in selling the NIMPA bonds. City has lent NIMPA the initial $20 million in bond anticipation note, the bands, prior to NIMPA's initial bond offering. And from City, we have Mike Shoemaker, Vice President from the Chicago office. John Miller, Managing Director from the Philadelphia office. Dan Cohan, Director from the New York office. Kevin Plunkett, the Associate from New York office. And at this time, I'd like to have invocation from Ray Schwartz, City of Rochelle's Utility Advisory Board member.
You bow your heads, please. Heavenly Father, we thank you for the opportunity to gather together. We ask you to bless the group assembled. We ask you to bless the deliberations and decisions made by the leadership. And last of all, we ask you to bless the food that we will partake upon tonight. Thank you. Amen.
And we're serving over here, and we can start with that table right there and just work around. You're first. Head of Northern Illinois Municipal Power Agency Management Consultant Team. The second speaker is Peter DeQuattro. As President and CEO of Prairie State Generating Company, he's responsible for leading PSEG in the oversight of Prairie State Energy Campus, which is now under construction. The campus includes a 1,600 megawatt power plant and Lively Grove Mine, which is 30 years worth of coal that we own. Formerly of Alcoa, successfully turning a power plant around, including acquisition and build out of Friendsville Mine. Peter and his wife Allie and 2 daughters live in Belleville, Illinois. Peter and Raj.
Okay. Thank you. Good evening, and appreciate all of you coming this evening. I think probably we talked about I was thinking about when was the last time I was here? Probably I think in about 9 or 10 years back. We keep coming and we keep telling you that the good project is there. Maybe you want to think about, you want to participate, and some of you, the forefathers, you jumped in and came into this project, and now the project is here. I think, I keep telling about almost like a football. I'm not much of a baseball guy, so everybody's talking about baseball today. But it's like, we are about the 90 yards. We got another, 10 yards to go to get this power plant built, and then the kilowatt hours coming out, so that you can see the benefits. But in the process, we did hire wonderful staff. I think later, Peter will be talking. He's the CEO of the project, and he and his staff are doing a superb job of bringing it to that operations level. So we'll be sharing with you some of the things, how we are building, where we are, and where we will be in the next couple of years time period. As you all know, this particular plant is located in southern Illinois, and there are about 200 million tons of recoverable coal adjacent to the project. And this is like Mike said, it's a 1600 megawatt supercritical coal plant. It's fueled by 6 million tons of coal annually. And by the way, about 30 years worth of coal, we already bought it and we paid for it, so it belongs to the project. So when you're looking at the project, 30 years worth of coal, it's with a locked-in prices, except the mining costs, whatever the labor, we need to pay, but otherwise, the reserves cost itself is locked in. And it's a newest power plant, and that means the EPA and others, they made sure that we use the latest, the best available technology we will bring into taking care of the whatever pollutants, sulfur dioxide, NOx, mercury, and then also the carbon itself. The only thing which we are not doing here is the CO2. There is no technologies for CO2, so and CO2 was not even considered as a pollutant until recently. Even still now, there's a lot of debate going in Washington. What do you call CO2? Is it a pollutant or non-pollutant? But that's a debate for the different day. Prairie State will deliver low-cost power for in the 8 different states. We got the partners. In the beginning, when we came about 10 years back, when we started talking to you, we thought that maybe about 70 to 75% of the project will be owned by Peabody, which is a coal company which was trying to build in the beginning. But as time went on, things changed. I think it's 95% of the project. It's owned by the public power, the entities, customer-owned entities. This is the largest private, investment in the project. And actually, I think 2009, this is the biggest construction project in the country. Not just the power side, not just the electric utility side. It was the biggest power project, the biggest construction project in the country, and employing almost like 3,000 to 4,000 people back there. When President Obama and others in the unemployment time period, they were injecting money to create the employment in Illinois. It's created by 8 different states. The money coming from not just Illinois, but it's coming from Ohio, Indiana, Kentucky, and then a little bit from Michigan and West Virginia, and a little bit Pennsylvania and Missouri. And Kentucky, I'm positive I said that. A lot of money coming from. We have a contract with Bechtel. Bechtel is the biggest construction contractor in the world, almost one of the biggest. And we retained them. So we made sure that we got the trained, experienced people are working to build this power project. And the air quality side will be, like I mentioned, there is a catalytic reduction for the NOx, and the precipitators for the regular particulate, and the wet flue gas sulfurization and the wet precipitator. These are the efficiencies. Probably Peter will be talking a lot more about the numbers, but every time anywhere you go, you think about 99.8, 99.9, 99.7. In that range, some of these pollutants are removed. So by the time you come back and you see that there's nothing, this air, which is coming out of his, almost all of these things are taken out. And as I said, it's located southern Illinois. It's about 70 miles southeast of St. Louis. I know St. Louis is in a Missouri, only a little bit of St. Louis and Illinois, but it's right there. And the entities, I told you, the 8 different states, 95% of money coming from into the Illinois, creating these jobs, and then for the future for all of not only kids but for the grandkids too, because this project will going to stay there, and Peter will talk later, but it's even at the CO2 side, it's a 15% more efficient than any of the existing power plants in the country. And the entities which are participating in the project are from Ohio and Pennsylvania a little bit, and Michigan and West Virginia. They are from the AMP side. The American Municipal Power, they're located in Columbus, Ohio, and they're the ones who brought almost like 22% of the project. Then Illinois Municipal Electric Agency, that's a sister agency in Illinois, and IMPA, that's my organization from Indiana. We have about 53 communities participating through IMPA into this project. And the Kentucky Municipal Power Agency, they created this agency to participate in the project, just like the NIMPA. And the Missouri Joint Action Agency, and Prairie Power Inc., it's a GNT, it's a co-op, and Southern Illinois Power Cooperative also another co-op. And Peabody, who started like 80 or 75% of the project owner, now they are 5% of the project owner. So 95% belong to the public power. And the technical details about the project and how the project is doing, and some of the pictures, some of the videos. Peter is a great guy. I think I'll hear Peter to take on from here.
Thank you, Raj. Can you all hear me okay? Thank you. Just starting from the high level, talking about safety and schedule, if we dissect the facility into the mine, the power plant, and the CCW management facilities, I have some statistics in front of you. Basically, from a safety perspective, the entire facility is being constructed with world-class safety statistics. I'm most proud of a couple of key points. The mine, since we started construction in summer of 2008, has been constructed without a lost workday. The power plant, I'm very happy to say that Bechtel, under their leadership, they are approaching 5 million man-hours worked consecutively without a lost workday. They're at about 4.7 million man-hours consecutively worked, about 12 million man-hours total worked so far. And throughout the project, their statistics have been outstanding. Their lost workday injury frequency of 0.15, that's against an industry average of approximately 2.0, so that's significantly less. Even the less intense injuries that are classified as recordable injuries, like someone has to see a doctor for an injury, get a stitch, or those type of things, their recordable injury frequency is running at a 1.56 against the industry standard for heavy industrial construction of approximately 6.0. So very good job there. Our CCW facilities, our coal combustion waste management facilities, our landfill, are also being constructed, while not as labor intensive, with excellent safety. We've had one lost work day, and that was a contractor's employee that who succumbed to some heat exhaustion symptoms and had to be treated by a doctor and couldn't come back to work right away. But I'm happy to report that employee is fine. So in total, the project that you guys are part owners, NIMPA's part owners, is being constructed safely. And then talking about schedule, as I dissect the schedule by the mine, the power plant, and the CCW facility, it's on schedule. The key driver there is the power plant. And we, under Raj's leadership as the chairman of the management committee, have been modulating the progress at the mine and the CCW facility to match the power plant's progress. In other words, we're trying to manage cash and not spend too much money in the mine or the CCW facility too soon. Staffing, This is a look at the Prairie State Generating Company staffing plan. You can see the blue is the mine, the red is the power plant, the lime green is construction management, and the purple is corporate services, or my direct and indirects, HR, legal, finance, etc. Right now we have about 162 people total. When I started in May in 2008, I was one of 22 people. And next year is going to be a big year. We're forecasting to get add approximately 400 people, primarily in the mine and the power plant. I'm also happy to report, and I think your owner's representatives, Dan and Mike as well, would also say that our team has put together really strong candidate evaluation processes, pre-qualification processes, and then once these technicians become employees of the Prairie State Generating Company and are tasked with their operating and maintenance and other support roles, they're going to be extremely well qualified. And we did a lot of work up front as early as 2008 with 2 local community colleges, put a degree program with the Illinois Eastern Community College for a degree mining program, and also put together an accredited program with Southwestern Illinois College for pre-test applicant testing and qualification. In terms of budget, I talked about safety and I talked about progress. In terms of budget, as from the Prairie State Generating Company, we received approval from our management committee in September of 2010 for a new budget of $4.933.5 billion, and that's an increase of about $599 million over the 2009 approved budget, about 14% increase. The prime driver on that was our renegotiated agreement with Bechtel, where we transitioned, and with the board's leadership, we had to do a lot of work to get Bechtel to renegotiate with us and go from a target price or cost reimbursable type of agreement where the owners had all the risk. The owners had all the cost and schedule risk, to a lump sum turnkey terms where now Bechtel has a lot more risk, and we think the risks are being appropriately redistributed when you look across the key points of the project. Mainly your interest is safety, quality, schedule, and cost. Those risks have been redistributed and the appropriate guarantees are in place as well. And so from an owner's perspective, it'll provide more certainty in project construction costs, and we move the risks of schedule, costs, and quality entirely to Bechtel. And in that agreement, we successfully preserved the completion dates that were in the original agreement of December 6, 2011 for Unit 1 and August 1 of 2012 for Unit 2. And where are we in the project? If you just look at cash flow curve for the project, and I was being asked about what are remaining risks in the project versus a lump sum turnkey. Of the 4.934 rounded projected budget or forecast for the entire campus, we've spent approximately $3.5 billion of that, and we have about $1.43 billion yet to go through the capitalization period of really late August of 2012. Let me talk about the mine. As I showed you earlier, the mine is about 64% complete. It's on schedule, and it's actually under budget versus our original budget of 2008, and then more so apples to apples comparison on scope changes in 2009. It's under budget. And progress to date, again, as I said, has been without a lost workday. It's just outstanding. Our focus is completing on the bottom development portion of the mine or the underground construction work, and then obviously staffing. This is a recent picture of the surface part of the mine. You got 3 stacking tubes here, and we have about 300,000 tons of storage capacity, live storage capacity at the mine. As Raj said, the owners own the coal. That's a wonderful position to be in. You're not exposed to coal, or fuel, which is the largest variable cost in power production. You're not exposed to hyper market derived pricing for fuel or the derivatives, like fuel adjustments and fuel adjustments for transportation. You actually own about, the project or the owners own a total of about 400 million tons of coal, but the way we're going to mine it with room and pillar mining or continuous mining will actually recover about 50% of that. And that 200 million tons of recoverable coal at a forecast usage rate of about 6.5 million tons is enough for 30 years of operation of the adjacent 1,600 megawatt power plant. The coal is at a depth of approximately 250 feet, and the seam is also ergonomically positive. It's a 6.5 to 8 foot thick seam. So that means most people don't have to walk around bent over except for Gary from Batavia. And we did, the first coal was mined in August of 2009, and as I reported out in September of 2009 to our management committee and some of the other owners, that I was very pleased to see that we did find the coal. So it was actually down there, so that's a good sign. All the above ground equipment is installed, and as I said earlier, our focus is on the underground work of installing conveyors, air shafts, and basically air ducting, the way we do it in the mine. And we plan to start stockpiling coal and actually start our first group of miners and our first section of mining in the first quarter of 2011. And from then on, it'll be about in 4 to 5 month intervals where we will add 3 more sections and the associated people and equipment, increase the production rate, stockpile the coal for inventory, and then get ready for it to be supplied to the 2 units. Each unit will burn about 10,000 tons per coal a day at full production. So that's about a unit car, a train of 100 cars of coal we burn today, and so we'll have to produce that. One of the common lines of questions I get is, tell me the difference between our mine and the Upper Big Branch mine in West Virginia. We're back in April where they had a horrible explosion and 29 people lost their lives. There's several significant differences that make it possible for me to say that what happened there won't happen here. The first difference is the mine itself and the mining conditions. We're mining at approximately 250 feet deep. We understand the geology. It's excellent geology, excellent roof, and floor conditions. The Upper Big Branch mine was over 1,000 feet deep, and that in itself lends it, and the geology was different, a little more variable, and the difference in pressures there obviously caused a difficult situation. The Upper Big Branch mine used not only the room and pillar mining technology that we use, where you leave a certain amount of coal, about half behind to support the roof, but they also used longwall mining, where an area of the mine is sectioned off and the equipment is put in that actually removes all the coal, and then the roof behind where it's just been mined is allowed to subside or collapse. So while done safely around the country, longwall mining in and of itself is not necessarily that much more dangerous, but the conditions at the Upper Big Branch mine are such they produce a lot more methane. Our mine doesn't produce a whole lot of methane. The Upper Big Branch mine produced more methane in a minute than our mine does in a month. How do we know that? It's the next point of why we're going to have a safe mine. Is we have state-of-the-art atmospheric monitoring equipment and control room at our mine that only 10% of the mines in the country have. Okay, and we're already fully compliant with the recently enacted Miner Act. We continuously monitor CO underground, which is an indication if you have a combustion situation going on. We also continuously monitor methane. We monitor methane 4 ways. We have continuous monitors throughout the mine. We have monitors with alarms on the equipment that's working at the face, that's mining the coal where methane would be liberated. We have methanometers on the people working on the face. And then our team has also said we want to add an extra level of safety. So in our processes and operating procedures, we've designed in that when a supervisor comes to check on his area of the face, he'll also do a spot check with a handheld methanometer. So kind of 4 layers of protection in that mine. And then lastly, we can also monitor, and we do monitor as anybody that's visited our mine and gone underground, we monitor our personnel's positioning constantly. We have big computer screens, and we have a distributed WAP system where we can monitor everybody's position. We know where they're at. So if there was an issue, an incident, we'd be able to know where the people are, be able to locate them. And this is a picture of a continuous miner, one of our miners in operation. And so I think you've all, through our monthly and weekly reports, at least the NIMPA board members, have seen kind of the stock pictures of equipment on the surface or the manufacturer's brochures. But this is actually a continuous miner in operation, one of ours. Here's the cutter head actually cutting into the coal right here. Another thing that we do, and that everybody does, is we spray limestone dust throughout the mine. That's why when you go into the mine, it's white. Okay? And we maintain that any dust that's on the mine floor has at least 80% uncombustible matter. And that's a recently enacted MSHA policy. This machine will move 20 tons of material, coal or rock, preferably coal, in 30 seconds. So, and there'll be 10 of them moving, running. It is a serious piece of machinery. It has a state-of-the-art scrubber. That's why you can actually see while it's actually mining, is there's a vacuum system on there that's sucking the air in to remove the dust, and spraying with water sprays so that the dust doesn't get sucked in, it gets precipitates out and falls to the ground. This machine is on tracks. It's powered by a 1,000-volt AC, and it's remote controlled by an operator who stands back away from doesn't get between the machine and the wall. We don't allow them to do that. It's called a red zone. And he stands back in the clean air stream. Again, another hygiene effort on our behalf. This machine is about 37 feet long. It's about 11 feet wide. It can cut from the ground up to about 12 feet high, and it weighs approximately 75 tons. So, and there's 10 of them. They're big machines. They're actually quite exciting to see work. This is a roof bolter at work. We have, I believe we have 10 of these roof bolters. They, again, are state-of-the-art. Each is manned by 2 people, and here's one of the gentlemen. This is a state-of-the-art hydraulic temporary roof support system. The miner, or in this case who's doing the function of a bolter, never gets under an unsupported roof. You can see here this roof is supported. There's roof bolts spaced, I believe, every 3 feet, and the screen already installed. And then where he's bolting a new area, the screen's already up there. He's standing under this hydraulic shield that if that part of the roof was to, a chunk of rock or coal was to fall off, he would be protected. And the same on the other side. He is installing. How this works is, first there's a hydraulic arm with an actuator on it that will spin a drill bit. Drill bit's hollow, and he'll drill a hole up through the whatever remaining coal seam there is in the rock. We have a nice limestone and then shale roof, very strong to bolt into. And then he'll put up a package of epoxy resin in there, and then run the bolt up in there, spin it, and it'll lock it in tight. And that glue will seal off in about 30 seconds. This is a picture. I think the people that came out and toured were very proud that we have the mine folks in their office building. So we're very proud, and we're going to show our management committee here at the November board meeting how we've laid out the buildings, warehouse, shop space, and the shower facilities that are going to house or be there to support some 400 people, and to make it what we want to be is the best mine to work at. This is a picture of the mine from early construction. We don't have the actual date stamp on it, but I can tell you from experience it's probably in July when we did the clearing and grubbing of the mine site. There's about 200 acres in fence at the mine. So I'm going to show you a series of progressive photographs over the last 2 years. This is a picture from August of 2009, so a year later you can see the progress that was made. The slope, how we get down to the coal seam is via a slope. It's 2 levels. The bottom level is, I think it's 12 feet tall, 22 feet wide, something like that, is where we'll drive equipment in and people in to get in and out of the mine. In the upper deck is where the conveyor is that hauls the coal out of the mine. That slope it's at an 8-degree slope, 8-degree angle to the horizontal. It's about 1,645 feet long to get from grade down to the coal seam, 230 feet deep at the area where the slope is, where we call the 0 point. Just to give you an idea of how we got there, well, we dug a hole, about 120,000 cubic yards of material, flopped it over here, and by doing surface work, we laid the first, is about 40% of the slope. And then we hit rock. And so then we had to use a miner to drive the slope in the rest of the way, and then we covered the hole in, planted grass. Other key point of the surface work, 2 air shafts. You have your intake air shaft here and your outlet air shaft here going in. And those were basically drilled, and then the drillings and they use water as a coolant and as then to carry the drillings. And you end up with a little pond here that when we're done drilling, you take the water off of it and then cover it up. 14-foot diameter steel down about 230 feet to the coal seam. So the air gets sucked in here and goes through the mine, and it's controlled, and then gets blown out here, and I'll show you how in a minute, with 2 exhaust fans. So these are kind of the 2 of the lifebloods of the mine. You can see by December 2009, we're starting to mine coal. We're starting the bottom development work, which is this slope. Now it goes all the way down here underground to the coal seam, and then we're tying in these 2 air shafts via a lattice work tunnels. We got our office building starting to take shape, and the surface work, about $40 million worth of work of the surface facilities is started. By March of 2010, the office building's about done, and you really can see the surface work starting to take shape, and they are about done now. And we're starting to, we're still mining coal as we're doing in parallel the surface and the underground work. And then August 2010, or currently, you can see the surface work is done. Just have to do some fine tuning, startup and testing. The office building, which is primarily the front part here, you got lockers and showers, warehouse and maintenance shop over here is done. It's about 60,000 square foot. So that's a little overview of the progress of the mine over the last 2 years. And now I'm going to take you on a little tour of the power plant, what it's going to look like when it's done. Oh, no, that's not good. Oh, sorry about that. I swear it was working earlier. Here we go. This is a 3D model, the Bechtel design model that was actually used as the power plant was designed and for them to design direction sequencing. For those of you that came on the tour, you're entering the main entrance of the power plant along the south road. Inside the fence at the power plant, we have about 500 acres that'll be what we call inside the fence. Immediately in front of you, you can start to see the size of the stockpiles, the live stockpiles of coal. We'll have about 5 days live storage capability in the power plant power block itself, and about another 60 days of what we call dead storage capacity at the power plant. Right in front of you is our raw water treatment plant. we'll have to treat over 25 million gallons of water a day that's used in the steam generators, but primarily used in the cooling towers. So as we turn and look to the east, you can see the Unit 2 cooling tower here. And just for those of you who've been on a tour, it's about the size of a football field. There's 24 huge fans that'll serve to for the air to water heat exchange process. You got to look at the power building itself, and these are demineralized water storage tanks. There's over 8 million gallons of storage capacity tank work on the site. As we look to the north, you can see more of our material handling area of the plant. It's quite big. This is the CCW pile. It's the coal combustion byproducts, bottom ash, fly ash, and gypsum from the desulfurization process. When burning 20,000 tons of coal a day, we'll produce about 11,500 tons a day of this product that'll be hauled off in rail cars, about a unit car train a day. These are chemical storage tanks, lime, acid, caustic, to be used in the water treatment process. We're looking to the west. This is the raw water pond, and that's the pump house. It's about 67 acres on the surface, 55 feet deep, about 45 acres at the bottom. It holds enough water for 30 days, or just under 800 million gallons. It's a registered impoundment with the EPA, and so it's, for some reason, the Bechtel people call it a dam pond. We're heading north a little bit more, and we're gonna, you can see this video is a little finicky, so we can't go too fast, otherwise it makes us all dizzy. Most importantly, it makes me dizzy. Cold storage pile, reclaim tunnel, about 5 days of cold storage there, where about 2/3 of it can be reclaimed automatically via hoppers located in the ground here. Looking back to the east, we're going to go by the ammonia storage tanks right here. We're going to use anhydrous ammonia that's part of the selective catalytic reduction process to remove nitrogen oxides from the flue gas in the selective catalytic, or the SCR. Again, the material handling parts of the plant are substantial, and this is just to give you a perspective on the size of the awaiting CCW pile. They even test the operability and maintainability by drawing in operators and maintenance folks. We'll use about 1 tanker truck full of anhydrous ammonia per day. Again, we're going to span east, northeast. That's our limestone storage dome. So it's weather protected. We have about 5 days of storage of limestone on site that's used in the desulfurization process. We'll use about 750 to 1 million tons of limestone a year. That'll come in by rail, a few cars at a time, about 3 to 5 a day, and we'll unload it via bottom dump right here in this building. As Raj talked about earlier, one of our advantages, one of your advantages, is the coal mine. You own the coal, you own the mine. Your variable cost of production of coal is well under market, and you're not susceptible to market drive pricing. You're not susceptible to being held hostage by transportation organizations, etc. Because the mine's located literally across the street from the power plant, and the coal will be transported across by a single single conveyor with a capacity of about 2,000 tons per hour. Now we're going to turn and head south, and you're going to get a picture of the size of the cooling towers. This is the Unit 1 cooling tower. You can see that there's 12 risers there, each feeding a section with they're over 35 feet in diameter fans. Again, that's the size of a football field. The air pollution control equipment on the plant takes up over 50% of the power block, and it represents over $1 billion in cost. And this is what it looks like in the 3D model versus the rest of it. This is the electrostatic precipitator, the dry electrostatic precipitator. This is the wet scrubber, and the wet ESPs up on top. And you can't see the SCR, but it's in this building here. and it's close to 200 feet tall. And as we proceed along, this is the east side of Unit 2. I think I'm very happy as an operator as well that we have a spare main step-up transformer that the owners had the insight to purchase. There's many stories of plants going down for extended outages due to premature electrical failures. Each of those transformers, the step-ups, the three main step-ups, and then the two generators, one in each unit, weighed in a little over between 400 and 500 tons, and they were transported via heavy haul from the Kaskaskia River with a temporary port at about 14 miles away. That haul took 2 days to go 14 miles. You can see the switch yard, and I'll give you some more details about the transmission work that was done, but the switch yard is essentially done, and these are the step-down transformers. We generate at roughly 24 kV. That'll step it down to 4 kV to backfeed the plant. We'll use about 8 to 9% of the actual generated electricity to feed the plant. You can see the circulating water risers. These are 6-foot diameter fiberglass pipes being fed. The underground pipes are 11-foot diameter steel reinforced concrete. Now I'm going to take you right into the turbine bay, and this is actually a maintenance door. You can see the tractor trailer parked there to simulate being able to haul something out of lifting bay. We're a supercritical thermodynamic cycle, 3,800 pounds pressure on the boiler. Throttle conditions are 3,800 pounds, 1,054 degrees Fahrenheit. Running at that higher pressure means we need ultra clean water. So we have full flow condensate polishing, which were the 3 domes that you saw just as we passed in. Stator cooling water pump for Unit 1, and this is just a little startup boiler feed pump for Unit 1. It's an electric driven, several thousand horsepower motor. That's good for about 30% load, and there's one each for each unit. These are the turbine driven boiler feed pumps. They have an integrated lube oil skid. There's 2 of them per unit. Each is good for 50% load. And if you were to couple those steam turbines to generators, they produce in total about 30 megawatts per unit. They're big pumps. There's Mike checking up on us. Look at that. And here's our vacuum pumps, Unit 1. So where we need assistance getting a vacuum off the condenser, we have 3 pumps to do that. Closed cooling water lines for cooling water systems, and then we'll see a plate heat exchanger, and then we're going to take the elevator up onto the turbine deck. Up we go. I don't know if you noticed, but earlier on we passed a couple rooms, and you notice the model actually shows the doors is open, so that when they're planning the construction of the equipment and the equipment placement, you don't get into an interference situation. We just walked off the south end of the feedwater deck for Unit 1. See the high energy piping, and it's a combined bay, turbine bay, that has both turbines and generators for both units on a single bay. We have 2 turbine cranes, each fully capable of moving the heaviest component. You can see the high pressure turbine at this end for Unit 1. Steam will go into that turbine, like I said, at 3,800 pounds PSIG, 1,054 degrees Fahrenheit. Go back to the boiler, be reheated to 1,054, go into the intermediate pressure turbine, and then into the 2 low pressure turbines here that run in parallel flow. Directly coupled, I think there's 10 bearings on this machine to the generator that has a water-cooled, hydrogen-cooled stator. Just again, you get the size of the place. Each unit has 6 coal silos feeding 6 coal feeders, feeding 6 pulverizers. We can make full load on 5 pulverizers, so we can have 1 out of service for repair and maintenance. And in that configuration, each pulverizer has to process a little over a ton of coal per minute. All looks pretty basic, series of boxes and some steel and pipes, right? And this is the boiler, just a big box with some pipes sticking out of it, right? Well, for those of you that visited, you know it's a little bit more than that. And thank you that cooperated. This is a picture from 2 years ago. Picture of the Unit 1 boiler building foundation being installed. You can see these little grass growing in here, but if you make out the little specks, there's over 7,500 60 to 80 foot long H-piles which serve as the foundation for the plant that were driven throughout this area. This right here is the foundation for the stack. That's over 5,000 yards of concrete in the ground right there. Here's the 11-foot diameter steel reinforced concrete circle water piping that's reached over for Unit 1's condenser. 1 year ago, you can see the remarkable progress made in a year. Turbine-based steels, turbine building steel is going well. In Unit 1, boiler steel's topped out. Those yellow boxes on top are a computer-controlled integrated lifting system called a strand jack system, with up to 9 winches are computer-controlled to lift super heavy pieces up into the unit to allow modularization. That's Elmo in that configuration. That crane, I believe, is good for about close to 600 tons at 400 feet of boom. Air pollution control equipment is going to go in here, and you see the stack. We've talked about this before. That's 684 feet, 4 3/4 inches of concrete, about 9,000 yards total that's poured at one wheelbarrow at a time. And today, you can see the cooling tower, Unit 2's cooling tower is done. The air pollution control equipment, as I said, is starting to fill up all that space. The dry ESPs, as you saw, and in the model, there's steel that's left out of here so we can put the SERs in place because they're big and tall, and then we'll build the steel around them and close in the building. Wet scrubbers, and you can see the wet electrostatic precipitator, the frame of it's already in on Unit 1. Turbine buildings enclosed, both turbine generators are in there. Unit 1's almost ready for lube oil flush. Here's the water treatment building. Again, I think this is $40 million worth of water treatment equipment, basic reactors, clarifiers to handle about a little over 25 million gallons a day. And then we get into some high-tech reverse osmosis equipment in order to make the demineralized water for the steam generators. As I said earlier, we're very proud about our safety record. And the way Bechtel and Prairie State's been doing it is we get everybody engaged from the leadership and down to every craft worker on site. And with the owners, we believe that all accidents are preventable, and we're really trying to prove it. And this is a picture of the craft stewards from each discipline that have taken on leadership roles in helping propagate our safety culture and that belief that we can build this plant without an accident. And Bechtel has also stood up and is rewarding people individually and not just in groups. There's a picture of 3 Boilermaker general foremen who have worked 6,000, 7,000, and 8,000 hours on this project without getting hurt. Talked about project schedule and percent complete. This is one of our project management tools, and part of our project controls systems is our earned value curve. And for those, I know you all have been involved since we started construction. We've been giving you different reports and different percents complete. This was the original curve from 08. This is a revised curve from Bechtel from the spring of 09, and now this is the curve from our new project. And this is where they re-baseline the project with some additional man hours, and it shows that they're on plan. The project schedule from a high level, Units 1 and Unit 2. Unit 1 is a 50-month schedule from full notice to proceed to commercial operations. It's pretty tight, and Unit 2 is 58 months. And you can see this is blocked off in the major components of it. Right now we're about here, where the boiler erection of Unit 1 is the critical path to that unit becoming commercially operable. Within that boiler erection, you got 2 key points. You have the weld out of the tubes, and you also have closing up the gas path. And this immediate challenge when I put this slide deck together in late September was the boiler hydro. But Bechtel's made some significant progress on that. So there's actually about 30 days float in that part of the critical path, and now the real critical path is the gas path complete. Unit 2's critical path is only slightly different. It's gas path type. How are we doing on quality? Well, starting with a partnership with all the building trades that includes a comprehensive drug testing and pre-testing, Bechtel's quality program is doing very well. As it says here, the weld acceptance rate, and for those of you who look at the glass as half empty, the reject rate of tested welds is under 2%. It's actually 1.4%, which is extremely good in this industry. An industry average number is more in the 5 or 6% range. So there's over 70,000 total code welds on this project. About 30,000 of them are done. About 2,000 of them get radiographic tested, x-rayed, and we went 4 months without a failed test. The last failed weld was October 5th. So instead of being about a 1.18% reject rate, we're about 1.39. Still very good. Okay, I kind of gave you general points, high-level look at the, at the power block, and I'm going to give you some details of just showing you just how complicated and sophisticated this is. It started with the prefabrication in the fab yard. As John was asking me how much laydown area you had on site, and it's about 300 acres total, is about correct, and this is over 50 acres of it here, and these are just boiler parts for units 1 and 2. So critical path for the project started 2 years ago in this laydown yard, and this is a prefabrication yard here and here before the parts are actually put into the boiler building. The boilers are big and they're complicated. Each boiler will put out over 7 million pounds of steam an hour at the 3,800 pounds, 1,054 degrees Fahrenheit. Each boiler is over 265 feet tall and weighs over 18,000 tons and has over 32,000 tube welds, which also further complicates it. They're called spiral wound universal pressure boilers. It is a spiral wound design in the furnace, which makes them highly reliable and have better turn down for operations, but they're more complicated to build. We started with deciding how much prefabrication to do, and these are some pictures of just sections of the boiler being prefabricated and getting ready to go in the building. This wall right here is over 100 feet wide and 60 foot tall and about 400 tons. And this is what it looks like being hung up in the furnace. And our largest lift on the upper furnace section was about 285 tons using those strand jack systems that I pointed to earlier. Still in the boiler, we have those spiral panels to put together. They're 1.25 to 1.5 inch diameter tubes that are about 0.4 inches thick of material, and they're 1 1/4 chrome material. So fairly difficult welds to make, and there's I think there's 6,000 or 9,000 of those type of welds to make in each unit. And there's over 90 panels that have to be installed. So they're big, they're bulky, and they have to line up. And as we finished the bottom of the furnace, we prefabbed about 480 tons of complicated section of the furnace, and then lifted it all into place. And if you can imagine, a lot of those tubes are on an angle, and you got these 1 1/4 inch tubes that have to line up with the other ones, and they did. After you finish the furnace, we have to lift over 1,340 elements into place and weld them out. And then you start putting the appurtenances on the boiler, the wind boxes, over 900 pieces, prefabricated into 8 sections that were lifted and some of them were 80 feet tall by 100 foot wide. After finishing the boiler, we work on the back end equipment. We have ductwork, fans, and air preheaters to install. And for those of you all that are familiar with power plants a little bit, air preheaters, you got a 63-foot diameter, 1,400 ton machine rotating on the shaft here, 2 of them that have to be installed in each unit. Raj talked about or mentioned the air quality control equipment earlier. One of the prominent pieces is the selective catalytic reduction equipment, or reducer. Each one of those on each unit weighs over 325 tons. I think they're actually total a little over 500 tons. But those were pre-modularized into 3 pieces in the laydown yard, walked over on heavy haulers, and the largest piece, the SCR itself, was lifted into place with 2 600-ton cranes with their winches computer synchronized, lifted 135 feet in the air, and then walked 125 feet, then lowered down into position, and they were placed to within a 1/16 of an inch of their intended position. The dry ESP, each dry ESP is huge. It's almost 2,000 tons of equipment, and it's not just a big box. There's over 5,700 electrodes and 700 collection strips per unit that have to line up inside to permit the gas flow at a certain pressure drop through there and collect that dust. The scrubbers are big and complicated. They're an exotic alloy. That's steel that's 6% molybdenum for its erosion and corrosion resistance. And it takes special welders to weld that up. 84-foot diameter scrubber module built in 21 rings, over 720 tons a piece, and a whole lot of pre-modularization was done there as well. Then you have the wet ESP. Itself is an exotic stainless steel. It's a complicated design, and it's work that was done on the ground to reduce the amount of work done at elevation and improve productivity. Then we start talking about other pieces that have to be put into the plant. I mentioned the 400-ton transformers. The condensers, 2 condensers, each of them arrived by rail with about 350 pieces that were in the laydown area. We put 350 pieces together, including the feed water heaters. There's 2 feed water heaters in each one, right there. That's the piping, the circulating water piping that goes in. They're pre-assembled and and then walked by these heavy haulers across the site, slid in under the turbine bay, and put on awaiting anchor bolts. So a lot of big work being done, and done to very finite specifications. So, done talking about the power block. Talk about transmission. There's over 38 miles of transmission upgrades that are associated with the Prairie State Energy Campus that we're looking after very closely. It's being built by Ameren. You all fund it, and then they reimbursing you for it. There's 1 mile and a 7-mile line that directly connect our switchyard to the grid, and then there's a 30-mile, 345 upgrade from the Baldwin Station switchyard over to Rush Island, so that involves a crossing on the Mississippi River. And this is a picture of a 600-ton crane boomed out to reach the top of those 440-foot towers. Here's some pictures of the river work being done. We actually shut down barge traffic on the Mississippi River for 2 days a couple weeks ago to pull the wires across with a helicopter. Then we have the landfill, or the coal combustion waste. We have over 1,200 acres there. And we have about little over 2 years worth of disposal capacity already constructed. And this is an aerial of that area you can see here. So we have a stage. Our folks have a very detailed plan for that. And that's a picture. We're going to have to unload 100 rail cars a day, and turn them around and send them back to the plant. With that, do you have any questions? Yes, sir.
What are your concerns regarding security?
As far as physical security, we run a very tight ship, both at the power plant, the mine, and the CCW facility and our training facility. And as far as cybersecurity, we are also guided by some FERC and NERC guidelines for that as well. But we run a very tight ship. We get over 1,000 attacks a week, and we haven't had one get into us yet. Yes, sir.
What do you do with the coal burning byproducts?
The coal burning byproducts, which are ash, bottom ash, and gypsum from the desulfurization process, those are commingled, run through a pug mill, hydrated a little bit so that they're not a dust problem, and put in a rail car and hauled to landfill. Some people have asked, well, why don't you sell it? I've heard of selling gypsum, all that stuff. We're landlocked. Just the fundamentals of the gypsum market haven't supported marketing that yet. Pretty versed in that. We did that in my past life. But with all the scrubbers coming in along the Ohio and Mississippi River, basically the supply has doubled for the gypsum market and synthetic gypsum. So that and demand has not doubled.
What do the landfills do?
It's our landfill. We have a lined liner in the cells, and it's protected from groundwater and surface water, and so it's stored there. And then once the landfill, each cell is filled up, it'll be properly capped, and we have monitoring wells and the appropriate water monitor and all that stuff. Basically, that's where it gets disposed of. Good question. Yes, sir.
I understand we're under budget, under the most revised budget. Aren't we really $1 billion over budget from where we were a year or two ago?
I was talking about the mine when I said under budget. So I was trying to give my mine guys a little pat on the back.
Okay. Overall, aren't we about $1.5 billion behind?
We're about, our original budget was just under $3.8 billion. And we've revised that due to scope and other, other changes. And our current budget, but with the new contract with Bechtel, with the appropriate shifts and risks, as I reported, about $4.934 billion.
So I'm still unclear as to how we're $1 billion above where we thought we were going to be.
It's primarily driven by the power plant. What are the specific drivers for the cost increases in the power plant? Okay. The primary drivers, we have about $54 million in owner-accepted change orders, or $58 million in owner-accepted change orders. Those are scope changes that we and the owners agreed to. For instance, the original plant didn't have a spare transformer, a step-up transformer, didn't have an auxiliary boiler. We spent, I think it was $5 million to upgrade the superheater material in the boiler because people with like units like ours were having premature failures. The rest of the cost changes or budget increases on the boiler are primarily labor or labor-related costs. Well, there's some quantity differences. Bechtel missed their estimates on boiler quantities, on the estimates of the quantity of material that need to be installed in the air pollution control equipment, and therefore they missed the amount of hours needed to install that equipment, and then their productivity estimates were off as well. So the bulk of it has been labor for those two reasons, quantity and productivity. Did I answer your question sufficiently?
So what did they do to change the productivity?
Well, under the cost reimbursable structure, we were, and Raj was, at the front of this with me and our project management people, really being difficult with Bechtel to tell them to improve the productivity, get the productivity improved in the workforce. They've had numerous productivity studies done, and now since that productivity, which drives cost, now they're doing that on their own initiative. It's not our risk anymore, and they're still working on improving productivity. So what have they done? They've improved their supervision to craft ratio somewhat, increased supervision. They've changed out entire teams, leadership teams at that construction site, and we're on our third project director, and they're on their third site manager, who's the actual construction manager. The current gentleman is actually a principal vice president in the company and was the project director's boss, and he basically took over for a subordinate 2 levels down to see the execution of this project to completion. So while we don't necessarily have the cost risk that we used to, nor quality, and the rework to get the quality, and Bechtel is very much incentivized by liquidated damages to get schedule. They brought the right people in now. Any further on that, on cost? Yes, sir.
Do you have any information about cost overruns and previous coal plants or nuclear power plants?
Absolutely. And I think when we...
I believe it's not fair.
Yes. And I think when we announced this revised agreement, we gave the NIMPA folks some studies, of current trends in the industry. And our cost increase, if you call it around 30% total, is really it's in line or less than other similar projects that started at about the same time that ours started, and it's actually significantly less than the average. So we showed you data that I think the average is over 60%, and the Energy Information Association is reporting, from 05 or 06 until current, I think it's close to 100% increase in material cost for similar projects. So we're not happy about the cost increases. We think that this lump sum turnkey project has some additional, risk money in it that now Bechtel has, but we think it's, well worth that investment. And if you look at this project on an installed cost, dollar per kW, which I know was in the NIMPA handout today, including the coal in the mine, but if you look at just the power plant and how it compares to current projects, it's still very favorable. And then by owning the coal and having owner's cost of coal, your dispatch cost is very, very competitive. Actually, it's still very competitive versus market, as in a lot lower than market. So even when you put in the cost increases, you're still in a very good position versus market. Yes, sir.
What was the contingency on the project? Construction contingency.
The original construction contingency, I believe, was $125 million.
What is it now?
Our current contingency understanding, we're about $1.3 billion left to spend. We have on the non-construction parts, we have about 5% of the to-go spend, and on non-power plant parts, and on the power plant itself, we have, I think it's 30-something million on the remaining spend. And that includes an allowance for taxes.
And that's unspent?
Yes, on the $1 billion unspent, roughly, for the power plant. We looked at our under the cost reimbursable structure, we had, I think, our change order rate and force majeure rate equated to under 3% of the spend. And when we started, and that included, the early stages of the project when we had little engineering done. When we locked up this agreement, we had about 95% of the engineering done, about 40% of the construction done, and we thought about 1%, I think 1.5% on to-go spend on the power plant would be sufficient. Yes, sir.
This contract lump sum turnkey, is that a firm fixed contract, or what's the terms of that?
It's a lump sum turnkey. There is a fixed price, and there are liquidated damages for schedule and performance, as well as bonus potential on schedule and performance. It also has terms, much more favorable terms, like I said, on liquidated damages and surety and the other backstops.
So Bechtel has to deliver the plant for the $4.9 billion.
Their contract is $4 billion.
$4 billion.
Yes.
So the 4.9 is
The 4.9 includes doesn't include the coal. That's in the number that the NIMPA folks have that I just saw for the first time. I don't remember it is, but in the 4.9 is the mine, is the power plant transmission, is the rail, is the water pipeline, gas pipeline, and then some other owners construction costs, about $40 million for construction management, and frankly, you know, the ramp up of the PSGC staff that occurs and is capitalized money because of the timing.
When you were your first chart, you had indicated percent complete on various different sections of the plan. Total was 67%.
Right.
And on the cost chart, we saw that you have spent 70% of the money.
Yes.
Can you explain that?
There is some front-end loading in the spend, and there's some front-end loading in our agreement with Bechtel. I mean, we are spending money. They are paying against defined milestones, and the curve, you know, is not flat. It's not linear.
Peter, one more comment. Why did the split turbine generator equipment we are required?
Yes, thank you.
That's a very.
But wouldn't that go to percent complete?
You buy equipment, you pay for money, and the labor company is the one you're talking to. So.
Oh, so is it that your percent complete is exclusively labor?
Yeah, so yeah.
The Bechtel folks have their rules of earnings, right? So they have their rules of how they credit earnings. So there is a certain amount of delay of taking full credit for a piece of equipment that's been purchased and paid for, except for the retainer that's on site but not yet installed. So yes, we would expect some step change in earned value once some of the equipment is totally installed. But to Raj's point, the air pollution control equipment, you know, several $100 million worth of equipment, it's all delivered, it's not installed. The boilers, several $100 million worth of equipment, all delivered early, not installed. It was all delivered when I got here 2 years ago. And the turbine generators, the same thing. And those are the three prime contracts.
The transmission expense, the capital for its transmission to the grid is included in the 4 or the 4.9?
4.9, I believe. I think. Thank you, and I know it's not in the 4, so therefore it's in the 4.9. I mean, I understand the focus on cost, but at the end of the day, from $1 a kW, it's very competitive. From a cost increase or escalation standpoint, very competitive, if not better than the average or in the majority of the projects that have been that are underway. And then your operating cost on this thing is on this campus by owning the coal and having owners cost the coal is still very, very competitive, even given the increased capital costs. And part of the increased capital costs there in the 4.9 are working capital increases, so not necessarily cost increases, but due to the change in the spend profile, we had to get some additional capital, working capital in place. And some of that was just driven by timing, where they're not necessarily cost increases, but it's money, costs that would have incurred, but since it's not going to be commercial, you consider it capital and not O&M money.
Based on the Duke Energy coal projects that are under construction right now, our cost overruns are
project compares, go ahead, Raj.
We divide from different from Minneapolis, so that's raise my hand. You're absolutely right. And we were comparing that. These two projects are about, two projects are not too far away from each other, and the vector was the same engineer and architect, so taking both of them, and Duke Energy project will come there. So again, I'm spending $2.5 over $1 billion, and they're struggling. Whereas we made sure that when costs started increasing, that's the time we said, how to make sure we control. That's when we went to Bechtel and we said, can we have this EPC contract with an outcome contract? That way, even if we pay it more right now, don't know, 2 more years we have time. So we will lock in and we have the price, we know exactly what it's going to be. We didn't like it, paying a little more money to the Bechtel, but at the same time, when we saw the prices increasing, both, we were watching in Indiana. And IMPA, we have ownership in Trimble County Unit 2, another project just coming online right now. So with the same size of the unit, and Bechtel had an EPC contract, we were watching the price, what's happening back there, and what is the new project, and at the trade state. This is where, Mike Buffington and other 7 board of directors, including me, and then the other 9, we concluded that saying that let's go back and have this EPC contract that we're locking in, and we know what it is. We don't need to worry about it every month, every day. It was going up every day, every month. I mean, every day next month we get up and we say, Bechtel, what's the price? Oh my God, oh my God. The productivity is not doing as well. The construction is not doing as well. We were nervous and we wanted to lock in. That was one of the reasons why Peter talking about negotiating contract and locking in. And now we know our total cost. Maybe under $20–30 million in the megawatt part of this part, but 99.99% of our expenses exactly. I'm glad that we were able to do this project. We like to clarify this more respectfully or
Any other questions?
Did Bechtel incur any consequences for their misestimations and their poor productivity and all that?
Not under the original contract structure, but under this contract structure, that's all their risk. And their other downside was reputation. So when this original cost reimbursable agreement was negotiated, there was no other type of agreement to be had in the industry. The industry was white hot with construction, as well as due to the 2 hurricanes in the Gulf, the petrochemical industry was sucking up all the major EPC firms that had the capability of and the experience in taking on a mega project such as this. So we got fortunate. We worked hard. The market came to us, and due to hard work, we were able to get Bechtel back to the table at what we think is a very reasonable cost and risk premium to finish this project.
I wanted to add, I think that, right, the previous contract, we took the risk. When we signed the contract, we knew that's what we're doing, but we had no option. Because nobody was there to provide the EPC contract when we were signing this contract in 2006 and 2007 time period. So we said, but that's the way traditionally all the utilities were getting. That's the same thing happened with you. You got a lot of power, more power than we had at that time, but they couldn't get either. They're going to go back into their contract. We will do engineering and architecture and design, and we will be your contractor. But whatever labor productivity or labor cost is yours. So, but like Peter said, when the costs started going up, we were nervous. We put the pressure on Bechtel. The one thing was they negotiate was project phase. Bechtel's reputation as one of the biggest contractors of the country. So we invited Mr. Bechtel. We did not go to the 1 level, 2 level. We went all the way to Bechtel. And we said, Riley, you want us to come here and see how we can do it. We sat together with the Riley Bechtel. He is the 48th or 47th richest man in the world. We said, you're the chairman of the board, you're the owner, we want you to come here and let's negotiate. And this is the final product which came out. Riley Bechtel, he's the one. In person, he came and he proposed right in the frames. So, like Buffington and other board of directors, we try to make sure that how to protect our valves, how to make sure that we get certainty comes into the total cost of the project. We put a lot of pressure on that, but some of the contractors will not be other things. And there's no contract that some of the guys to see how you can put some pressure, and yes, we do.
Any other questions? Okay, with that, I thank you all for your attention.
Thank you for coming. Have a nice evening.